We have Dr. Gordon Brebner, who's a senior fellow at AMD. He contributes to the corporate vision and strategy at AMD, while also leading an international research group that's investigating novel forms of programmability in high performance, low latency, and trustworthy communication networks. Translating the results then into successful products with an emphasis on ease of use through a particular focus on domain-specific languages and architectures. Most recently, this led to the Xilinx acquired, which was acquired by AMD in 2022, P4 programmable SmartNIC products. Gordon currently co-chairs the P4 architecture working group and previously co-chaired the P4 language design working group. He has also worked at the University of Edinburgh and moved to Silicon Valley back in 2002, but he continues to have affiliations with their programs there. So Gordon, welcome, and please take it away.
Thanks, Larry. Good morning, good afternoon, good evening, everybody. So I've chosen a slightly pretentious title, but I think this is a moment at which P4 can certainly have an expansion phase. So my kind of, my starting point is a happy birthday to P416. I realized actually 5 years ago at the same workshop was when P416 was launched. And at the time I was co-chairing the language design group, so I had the pleasure of revealing P416, the spec coming out. As you may tell, it was running a bit late. We didn't update it to be P417. But it came out 5 years ago. So 5 years on, it's a time for reflection. So the first thing one does in these kind of circumstances is come up with some contrived laws about what might happen next. So this is a little roadmap of my own experience in this space. And you see I'm dividing like proprietary and standard languages, and then more subjective ad hoc and purified languages. And for me, the journey began with a language called G for packet processing, which was ad hoc. We were working with Bell Labs at the time, and it was for their needs. And we suffered the kind of 3-year itch of realizing the constraints on that. So more purified language emerged about 3 years later, which we called PX. And the trouble was, that was proprietary. This was Xilinx at the time, and it was within the company. So that led to what we call the 5-year itch. And at that time, P414 had just appeared. And I think it would be fair to say it was in the ad hoc category. It had a lot of unusual features and bloat, and it was tied to particular architectures. And so 3 years later, P416 emerged, which is where we are today, and that's the birthday we're celebrating. So that leaves the question, do we have another 5-year itch, or what's going to go on? So that's really my subject today. At the time we were doing P416, the worry was we might end up creating a new version of the language every couple of years. There would be a P418, P420, and things like that. And no one's ever going to adopt this language because it changes frequently. But it's turned out, P416 has actually stood the test of time. And I think now the question is more about expanding its scope rather than doing fundamental changes. So that's my kind of topic. And I think the major contextual change is kind of switches, where all that anyone was talking about, at the beginning, is the rise of NICs. And this kind of multicolored block diagram you see is something I've used over the last few years. My message was for a P4 person, if we could have switch style architecture where you've got sort of ingress and egress pipelines between Ethernet and a switch fabric, if you recognize the standard P4 pipelines there. If you look at a NIC style architecture, it more or less looks like the same thing, except you just substitute host CPU for switch fabric. And so from a P4 angle, programmable data plane is what counts. The kind of marketing bloat, if you like, we've had is, we've latched on the term NIC in the P4 community, but as folks will know, all sorts of terms have come across. SmartNIC, I heard Ben say SmartNIC just now. DSC has come from Pensando. IPU's been invented recently by Intel. DPU's come up from Mellanox. SmartNAC is something I liked a few years ago for network attached compute, network attached storage. So really today is not to go into that philosophical debate. We had a panel yesterday on kind of IPU, DPU issues. I think the key thing for P4 is what we've got is some kind of network attached hub, which by definition has a network connection, and that's what matters most. The diversity of marketing names corresponds to technical diversity, in terms of what components are actually on a quote NIC. So that's what I see as the big, 5-year step change, is moving on to thinking a bit from, thinking about switches predominantly to thinking about NICs. Before I get onto that topic, I should mention I'm not a marketing person, so I won't dwell on this. Is in AMD, or Xilinx's was until earlier this year, we have the SM family of SmartNIC products, and that does various hardware offload. For the P4 people, and that's who's on the call today, the interesting things I'd point out is, if you look at the supplied internal data path, which is doing these kind of standard functions mentioned, including OVS offload, this was actually implemented internally using P4. So it's a use case of certainly the most complicated pieces of P4 I've ever seen for real. And then it's kind of open-ended. The data path allows users to add their own plugins of the P4 modules. So this is very much a kind of SmartNIC that's P4 oriented, both in its internal implementation and in how people can use it. So that's kind of shrink wrap product. On the more research side, for my own group in what was Xilinx Labs, we have a thing called OpenNIC we've open sourced, which we kind of designed initially for our own purposes, then shared with a bunch of researchers, and it's kind of taken off and we've open sourced it. Now, and really this allows you to build your own bare metal NIC. It's got the network interface and the host interface and drivers for that. And you can implement data paths to clock frequencies, and you can use the P4 to FPGA compilation for that. So this is our kind of researcher offering that allows you to get line rate hardware, as opposed to on the previous slide, that's the official AMD product, which is more the shrink wrapped user experience. So that's kind of what we're doing on P4. But returning to my theme, this is really the big claim today is I think there's going to be democratization of P4. I'm still in democratization, in the context of programmable networks. It's always been democratization of switches and networking and such like. I think actually the rise of NIC applications instead of switch is actually going to lead to much more opportunity for people to work with P4. And the kind of rationale here is the original focus on switches is, well, one practical point, leaving aside your virtual switches, your Ben's topic, there aren't actually many accessible P4 programmable switches out there. And what switches exist in real networks is not many people are allowed to program them. And in fact, the people operating the network may not want you to reprogram the switches frequently. So I'd see, obviously, research has tended to focus on switches, but I describe that as more theoretical rather than getting your hands on practical networks. And obviously there's major counterexamples to that, but I think that's kind of boxed in P4 a bit in terms of just thinking about switches. Whereas if we're looking at NICs, well, first already from various companies, I mentioned AMD, there are many others. Now there are P4 programmable NICs of various flavors with different marketing names. It's easier for people to get their hands on systems which are housing NICs rather than networks with switches, so you can get something under your control. You can certainly imagine frequently reprogramming NICs. Even if you're reprovisioning virtual machines or whatever, you can imagine reprogramming NIC functions to correspond to the needs of your particular customers. And I really see this coming to a kind of blossoming of P4 related research. So this is what I have in mind for the 5-year itch, is not kind of inventing a new language or whatever, but motivated by NIC applications that a lot more people could do a lot more research, and things can expand in P4 world. So, elaborating that theme slightly, bringing out the P4 sun from behind the cloud, no cloud pun intended. If you look at a switch, and if it's a line rate switch, then you're kind of limited in terms of what you can do given the time available. The standard PISA model has been around since the dawn of P4 for your basic switching functions. There's got a black box in there, the traffic manager, which is the thing that schedules and queues packets, but is untouchable from P4. There's been a lot of interesting research examples around in-switch compute, but someone who's been with P4, I'm calling it P4 abuse here. It wasn't really intended for elaborate arithmetic functions or serious compute. It was more light touch packet processing compute. So that's kind of boxed it in. But if we look at the NIC side, then obviously still have the standard packet processing functions, standard pipeline. Because you're kind of terminating connections, you have end systems. Then you start getting interested in transport protocols and higher protocols, customized protocols, and that's where P4 programmability can help. You then got the final termination. You're going to a host, or perhaps going to storage if it was network attached storage. Offloaded infrastructure functions. That's a hot topic. Is ultimately offloading all of the kind of infrastructure from hypervisors into the NIC. Generally network attached compute, including machine learning functions, is diversifying NICs. So this kind of opens up the question of how far would it be sensible to broaden the domain covered by P4? Because at the end of the day, it's meant to be a domain-specific language, so we're not going to turn it into yet another general-purpose programming language. But I think the interesting challenge over the next 5 years is how could this be broadened in a clean way, not an ad hoc way, but try and get the clean extensions overall. So for the rest of the talk, I'm going to talk about a few extensions who've been sort of hobby horses of mine over the last few years, just to put them down on the record and sort of set the scene for what might be interesting areas to look at. To get to the first one, this is a bit of standing back, as Larry said at the moment. I'm co-chairing the architecture working group at the moment, and sometimes you stand back and wonder about what you're doing. The reason there's a language working group and an architecture working group was the key thing in P416 was to separate out the kind of language capabilities expressing packet processing from the underlying architecture within which that was embedded. In P414, these were completely interlocked together. And I think this separation idea has certainly lasted 5 years and will continue to last. The other notion to encourage portability was to define standard architectures, which has been the work of the architecture working group. The notion of externs, which was something P414 didn't have, so you can have this kind of open-ended pipeline, and you can have standard libraries of externs. I think that stood the test of time. I'm beginning to wonder about standard architecture models. Supportable switch architecture has been around for multiple years now. The purple box shows what's currently on the web page of the latest version. But I think that was uncontroversial when it was defined, because it was more or less saying it's going to be PISA-like and with some extensions. What we've had, it actually kicked off 4 years ago in some discussion at this workshop in 2018, is a portable NIC architecture. It had meetings towards the end of 2018, then it went into hibernation, got kickstarted again end of 2019, and then it is running today, and a draft spec came out actually the workshop last year. I mean, one thing it's taught me is, in the NIC world, it's less clear what might be portable already. There's a lot of diversity, never mind the naming of NICs, but in terms of their functions. So it may be, which is not the aim, that defining something or people trying to work to a portable standard might actually stifle innovation, in which case it's gone in the wrong direction. So that's a work in progress in the PNA group. I think Andy yesterday gave an update on the status from the PNA group, but it starts to ask questions about are these portable architectures helpful, or are they just enshrining the status quo in the interest of portability, when in fact most people don't actually write portable complete systems in P4. So the kind of view I see this is my, instead of P4 architectures, I've got my P4 archipelagos. So really seeing a system as a collection of kind of islands of P4 rather than some architecture containing pieces of P4. So the naming of the islands here is purely suggestive of different islands. This is not meant to be a standardization discussion. But the key message is, kind of P4 island is a subsystem, which can be designed in a modular way and using, modular constructions and include externs, but it's not the complete system. These are components which can be reused in diverse systems, and we don't attempt to kind of impose an overall architecture on them. So the kind of example is, if you look at the AMD NIC, SmartNIC, which I mentioned a few slides ago, it's actually built using 9 different P4 components. It's not defined as part of some standard architecture. These are 9 components, and then there's connectivity between these components and a small number of other components. The vast majority of it is built using P4, and then you can add, or the user can add, their own extra P4 components. So you're defining this kind of collection of islands, and some kind of connectivity between them. My gut feeling is, as P4 moves onwards from the switch world, was a more sort of standardized and simplified way of doing packet processing, to more diversified NIC world. That's something a bit more loose. When you have clear interfaces to subsystems, that certainly matters, but maybe you don't worry so much about standard architectures anymore. At this point, I may have put myself out of a job on the architecture working group, but hopefully not. So this is a long lead into my first kind of P4 extension, and believe it or not, this is dragging up something I talked about before P4.16. In fact, when we were first discussing P4.16, this is back in November 2015, and the idea was not to just use standard architectures, but have a way of programming the architectures, as well as a P4 description of the packet processing. You had a way of describing the architecture, the components and connectivity between components. And if you've got really good eyesight, then screw up your eyes and look at the typescript in the bubble there. This was the little language we had, and this was a slide from a talk. There was a demo at the workshop, and we showed that this could be created and compiled. The way of describing the connectivity was based on CLIck, which some people listening will know about. That came out of MIT in 2001. It was the work of Eddie Kohler, and we were using it for other reasons at the time. So we used a CLIck-inspired way of describing complete systems. The kind of the catch, and you may have been thinking this on the previous slide showing my archipelago, is this was implemented using an FPGA. So given that's programmable hardware, programmable logic, you could actually create these components and then connect them together in ways you wanted. Something like this obviously is not so popular for a kind of fixed hardware architecture, brackets, most alternatives to FPGA, where you do have your components and connectivity between them. But I think with the rise of more general P4 pipelines appearing as part of NICs or collections of pipelines, I think there's more hope for hardware. And of course, you can do this in software. That's not a problem. The other rationale, if this wasn't an implementation flow, was it could also be a way of defining things precisely, things like PSA or PNA specifications. Instead of describing in English what there was and how it was connected, you could connect them together. And you're revitalizing the thinking from 7 years ago. This is a kind of thing that would be useful if you have islands, and in the P4 world, you wanted to describe something about how the archipelago works and how the islands interact with one another. So that's one possible future direction. So that's always been one of my kind of enthusiasms, which I'm dusting off a bit here. Another thing towards extending it, which we did some work on a couple of years ago, is extending the processing model for P4. Currently, as people will know, it's kind of implicit. A packet arrives and something happens, or packet departs and something happens, and that's a kind of trigger for events. In this work with a paper from Hotnets here, with Steve Ibanez, then at Stanford, with McEwen, and Gianni Antici in London, was to broaden this to have a model where you have other kinds of triggers. So list here some examples, not just packet arrivals, departures, but buffers running into trouble, or the link status changing, timer expiration for various protocols, and things like that. So that was to have a general kind of event-driven model, and then that has applications in all sorts of things you might want to do apart from your basic packet switching. So this has always been a kind of gleam in the eye. It's related to this language architecture discussion. It's really kind of loosening up the architectural context, if you like, around the P4 standard parser, match action, deparser, which is doing the work. It's how that work gets stimulated, and in turn, what events it could stimulate. So that's one of the things that was always of interest. Another long-running gleam in the eye I alluded to for the standard switch model, the traffic manager, the queuing and scheduling side was always a black box, and it was just there and not referred to in P4, was tackling this is a potential P4 extension. For a short time, we had a working group or sub-working group in architecture looking at this. It somehow faded into disuse, but that didn't mean the problem wasn't interesting. And we were looking at how you might have abstractions to describe scheduling algorithms. And one thing we're looking at very closely was the P4 model, which came from Anirudh Siva-Raman, over 5 years ago now, and we did some FPGA implementation of that as a model where you describe this scheduling or shaping algorithm in terms of priority queues and how you choose a priority for that. So this is one idea of finding a clean way of extending P4 more towards traffic management. This is not packet processing as such. This is a different but related function. So programmable traffic management has always been a gleam in the eye. Another one which becomes pretty important in the NIC context, where you've got kind of end systems, is looking at transport protocols. And if you're just going to use TCP or RoCE or something, fixed protocols, it's not interesting. But we're all P4 people, so you're having customized transport protocols is of great interest. And yeah, really for that, three main areas where P4 needs some extensions. One is congestion control mechanisms, which are at the heart of transport protocols, segmentation and reassembly. That the notion of cross-packet effects doesn't really feature in P4, and in general kind of statefulness. And I'll shout out here Mina Rashlu, then at Princeton and now at Cornell, did some notable work on that. We've done some work on congestion control. And as you may have heard yesterday from Andy Fingerhut's update, the P4 applications working group is about to embark on looking at congestion control as a kind of P4 programming problem, because it certainly, as the rough diagram indicates, a plethora of possible approaches to congestion control. And I think this is a great area for P4 to expand its remit into, let's say, protocol processing as opposed to just packet processing. And then there's lots of other stuff. The NIC context has inspired various things, like programmable DMA towards the host and how you express that. A hot theme, as Andy mentioned yesterday in the PNA group, is having data plane writable match action tables, which has been a glint in the eye of the language group for many years, but has got a kicker from the NIC discussions. Stateful segmentation, non-trivial compute. Currently, externs in practice have to be kind of low latency, short time scale things. What happens if it's non-trivial compute? And adding cryptographic operations in some kind of standard way. And if you look at the program in the workshop, you can see various people with various ideas on what might happen. So the message is, the P4 firework can explode in this controlled environment. And my personal feeling is NICs, or whatever you want to call NICs, are a catalyst for the next stage of P4. So just to wind up, what are my main takeaways from this? One is P4 is alive and well. We're not going to have a new language, 5 years on. And I really think there's a liftoff point for expanding it. This change of emphasis from just talking about switches to NICs will mean democratization, much easier for people to get their hands on hardware and program with P4. The NIC context just gives the way of defining extra functions you want in natural adjacency, not turning it into a general purpose language, but what's a natural extended domain specific language. I mentioned my custom P4 archipelagos, my islands of P4 components rather than standard architecture. That's my controversial theme for the architecture gurus. The final point is I think there's great opportunities, everyone listening, for people to put effort into thinking about this next stage. I certainly want to be part of it, and the more hands, the better. Often we have trouble getting committed people doing committed things in the P4 world, which is why something stall. So the more people, the better to get actively involved in p4.org. So that's it.
Thanks, Gordon. Very thought-provoking. So it seems that you've laid out the path of destruction for P4. It will explode into an ad hoc programming language because there's so many demands, so many opportunities on the one hand. How do you, what's the discipline? What's the litmus test to just say no to preserve the good things about P4 while tackling these new opportunities? Or maybe another way of saying that is, how would you prioritize what could be added to P4 that would get you the most bang for the buck without sacrificing the good aspects of P4? Maybe an impossible question, but I think it's the key one.
Yeah, actually, I from what Larry said there, when I was picking that graphic, I was originally going to use a bomb, but I thought that would look too destructive. So I chose a firework to make it look exciting, not the destruction of P4 into fragments of ad hocness, etc. So in case there was any doubt, I'm very enthusiastic about my firework here. Maybe I could have chosen a better firework, like a rocket exploding into the...
Well, I mean, there's huge opportunity. I mean, one of the things, the democratization is huge in the sense that everyone can now play. And I was actually going to ask a follow-up question about, lowering the barrier to entry for students to start programming these things as well. But
yeah, I mean, I think in terms of what are the priorities, this is something that's come up in our PNA group discussions, and this data plane writable match action thing has emerged recently as something that everyone agrees something should be done. But that's kind of mechanical. For me, of the things I mentioned, I think programmable transport protocol doesn't just inching P4 up from just being stateless packet processing towards more stateful protocol processing. That would be probably my number one, container for, keeping it within bounds, but, not exploding too much. Obviously, if we're going to non-trivial compute, it could just turn into anything. So, by that, I'm thinking network-related, compute function, like, for example, it might be a scheduling algorithm or a congestion control algorithm, and how that, not expressed using P4 syntax necessarily, but compute within reason within the domain.
Is there a reasonable way to draw a line between P4 and other slightly or even much more expressive mechanisms, BPF, for example, where a clear line is drawn? This is P4's domain. This is eBPF's domain, for example. Does that kind of strategy make sense, or do both try to capture as much market share, so to speak, as possible?
Well, funnily enough, eBPF features in my world as well, since there's demand for eBPF and hardware accelerated eBPF, particularly in my part of the world. If I was crudely characterizing that, eBPF, there seems to be people who prefer to quote, program in C, and obviously it's extended from the original packet filter thing into, you can write little C-like fragments to express it, whereas P4 I see as a higher level, more domain-specific language than C stroke eBPF, but they're certainly complementary. I mean, there's a P4 to eBPF compiler, which Mihai Budai did at VMware Research. So you can go in that direction if you want to have the best of both worlds. But yeah, I mean, I think P4, it started out essentially expressing, the capabilities of a switch pipeline. And I think, if you look at the language design working group over the last 5 years, I'd see it was in the pure category, but purification. The language is, there aren't staggering increases in the functional coverage. It's more tidying up the language and making it a cleaner language, which is also a good trend. But part of the issue is, when we say NIC, there's already this diversification. What people mean by NIC, the smart NIC, the DPU, the IPU, whatever, is potentially that could open a lot more doors to P4 sprawl. So I think somehow we had to have a core agreement on, what is the kind of P4 relevant aspects of a NIC.
Well, I mean, it's a domain-specific language. You need to define the domain.
Yeah,
exactly. The domain could be the universe, but that's probably not quite the right way to go.
Yeah, I think at the moment, the NIC world is still defining its own universe.
Yeah, exactly.
Even before the marketing people get involved with all the different names, it's kind of, you can see more and more stuff potentially being offloaded to the NIC. And if you take the term DPU, data processing unit, which in some ways I like, on the other hand, it's the most dangerous name of all, because it could mean anything.
Yeah.
A data processing unit could cover.
You could call that a computer, yeah.
So yeah, it's kind of related. I mean, the NIC world is still, in its infancy, or the smart NIC world is in its infancy. So I think P4 will kind of go hand in hand with that kind of evolution. Yeah,
well, I appreciate your thoughts. You've actually generated or spawned a whole set of questions. If you have time to go back and answer them, we've kind of touched on the themes of the questions, but there are some specific ones.
Right, yeah, I can capture the questions.
You can. The Q&A, you can answer them if you have time to do that. Continue to answer them. Thank you for your presentation and your thoughts.